for tutorial chapter 2 is supposed to start in week 3. Basically week 3 kita kalau betul-betul minggu depan lah week 3 kan? Betul tak? Kalau ikutkan yang minggu kita dah minggu kedua ni, nanti minggu ketiga. Okay, so week 3 hour 1 until week 4 hour 3, dia 6 jam tutorial untuk this chapter 2. So for 2.1 and 2.2, they have 3 hours tutorial. Jadi setengah daripada chapter ni lah. Dan the rest lagi 3 jam tu belongs to 2.3 and 2.4. Okay, for non-face-to-face questions, the learning objectives, they ask you to explain endothermic and exothermic reactions using the complete energy profile diagram. Okay, so yang ni endothermic and exothermic, you already know. You have, can I know the y-axis for this energy profile diagram?
Energy.
Okay, energy. Lepas tu, x-axis dia?
Progress of reaction.
Yes, progress of reactions. Dia not necessarily time lah, kita nak tengok progress sahaja. Okay, awak kena tahu macam mana nak lukis. And then, you need to know how to calculate the heat change in a constant volume calorimeter, bomb calorimeter lah. Maksudnya dia dah masuk dah 2.2 sikit. Sebab 2.1 tu just definitions, 2.2 tu is the applications. Basically, 2.1 ni akan digunakan dalam 2.3 dan juga 2.4. Jadi mesti strong 2.1. And then ada juga soalan, maybe in face-to-face ke face-to-face. Calculate the heat change in a constant pressure calorimeter. Kita ada berapa case calorimeter kita belajar semalam?
2.
3.
Constant volume dengan
Jenis calorimeter 2 tapi cases dia 3, ingat tak? Yang saya cakap ada case dia dalam 4 calorimeter tapi dia bukan dalam setup calorimeter yang spesifik bomb dan juga simple tu.
Yes, miss.
Ada 3 tau. Satu, okay. Ada 3 dalam 2.2 kita ada 3 cases. One yang dia melibatkan heat exchange sahaja. You ada benda panas, you ada benda sejuk tapi tak ada pun setup of simple or bomb calorimeter. Itu pun dikira calorimeter tapi itu setup yang very simple lah. Lepas tu second case kita ada bomb calorimeter where usually we have heat of combustions. And then untuk simple calorimeter kita ada heat of neutralizations ataupun heat of solutions. Okay, so the first question is the standard enthalpy of formations of nitric oxide gas NO is positive 90.7 kilojoule per mole. So this positive 90.7 kilojoule per mole belongs to endo or exothermic reactions. Endothermic sebab dia positive sign. Okay, bila dia kata kilojoule per mole, bila cakap per mole and you refer to the standard enthalpy of formations, can I know siapa yang kena 1 mole?
Product.
Siapa produk yang kena 1 mole tu?
Nitric oxide acid gas. Sorry.
The nitric oxide gas lah, only the NO. Okay, kita tahu kita keepkan only the NO 1 mole. The rest awak buatlah macam mana asalkan NO tu tak bergerak, 1 mole only. Okay, define the standard. Saya rasa saya tak buat jawapan ni sebab saya tak buat jawapan ni. Kejap tak apa, kita discuss dulu sekejap lagi, saya tunjuk jawapan dia. Okay, so define the standard enthalpy of formations. Standard enthalpy, and every time awak nak explain tentang enthalpy, awak kena first emphasize heat being released ke, absorb ke, change. Kalau formations, kita ada heat apa?
Heat is absorbed.
Heat absorb saya dengar lagi. Ada siapa lagi nak jawab? Heat apa lagi?
Change.
Heat change lagi. Absorb dengan change saya dengar. Okay. Maybe ada yang cakap absorb sebab dia nampak positive sign kan?
Yes, miss.
Okay, betul. Tetapi kita ada 3 cases when we talk about definitions of enthalpy. They either be only heat release, only heat absorb, or sometimes it can be either heat release or absorbed. Bila dia boleh jadi dua-dua, nama dia adalah heat change. Even though the value is positive, if the questions ask for standard enthalpy of formations, these formations require heat change. It can be either positive or negative. Jadi, the definitions, you must emphasize heat change.
Okay, miss.
Okay, so heat change. Okay, tu je ke? Lepas tu kita kena sambung. Kenapa heat change? Apa yang berlaku? Okay, heat change when 1 mole of, bila kau sebut
Nitric
formation.
oxide gas.
Okay, nitric oxide gas is the specific. Kalau soalan tak minta specific to this species, awak boleh cakap heat change when 1 mole of formation sepatutnya reactant or product.
Product.
Okay, 1 mole of product is formed from, macam mana NO terhasil?
Each
Adakah
element.
from apa? From its element. So its element sahaja. Kalau element, we know N is N, O is O. Or they must be in other states, macam N something ke, N3
In
ke.
their most stable states.
Ya, in their most stable state. Kalau N, kita tahu elemen dia N, tetapi dia paling stabil dalam keadaan diatomic. Means dia kena N2. Kalau O pula, elemen dia O, and then dia sama case macam nitrogen, oxygen must be in O2 gas. So we must first N2, we must first have N2 plus, kena ada ni lama. Dia kena ada dia punya phase. Gas plus O2 gas to form NO gas. Okay, so sekarang yang kita nak keep 1 mole is only this NO. Means what will happen to your N2?
Times by half.
Okay, times with half. Okay, what about O2?
Same.
Also half.
Half juga. Okay, so by having half N2 and half O2 react together, they will form 1 mole of NO. So this is what meant by standard enthalpy of formations. But then, don't forget to include this delta H. Equal to berapa? Dia dah bagi tahu. Positive 90.7 kilojoule per mole. Sorry saya tulis dekat laptop. Okay, so ini kita panggil apa equation ni?
Thermochemical equation.
Yes, thermochemical equation. Apa beza thermochemical equations dengan chemical equations biasa?
Dia ada delta H dekat belakang.
Dia ada delta H dekat belakang. Kalau you ada positif, tolong emphasize positif. Kalau ada negatif, tolong emphasize negatif. Okay. Right, kita dah jawab A dengan B lah basically. By referring to 1A, explain why the standard enthalpy of elements is 0. Kenapa awak rasa dia 0? Kenapa awak rasa kalau elements tu, setiap satu elemen yang saya cakap, kalau dia paling stable, dia 0? Kenapa awak rasa dia 0?
Sebab dia dekat most stable state.
Yes, betul. Mari kita tengok sikit apa jawapan suggestion answer dia. The standard enthalpy of formations of any element in its most stable state form is 0 because there is no formations reactions needed when the element is already in its standard states. Macam saya cakap semalam lah, bila dia dah sangat stabil, dia tak perlu bother untuk release or absorb. Bila kita sebut release or absorb, dia perlu buat something. That something belongs to bond breaking or bond forming lah. Okay, ni ayat yang proper dia. No formations reactions needed when the element is already in its standard state. Okay.
Okay, Miss.
Alright, betul. Soalan yang seterusnya kita ada sketch the energy profile diagram for the above reactions. Kalau ikutkan kita punya delta H is positive. Can I know whether reactant or product yang got more?
Product.
Product got more, maksudnya dia from reactant bawah, product atas, so nanti dia punya rupa dia begini. Okay, bila awak lukis ni, awak kena ada labeling on your y-axis and x-axis, and then buat sini reactant, sini product. Tapi jangan tulis reactant, tulis product, tulis dia punya reactions yang awak buat tadi. Kan kita buat half N2 dengan half O2 kan. So letak kat sini half N2 and half O2 together with their states, gaseous states. And then dia akan ada form, this is the maximum potential energy, we call them as activation energy. Lepas tu kita dapat kat produk dia adalah NO sahaja, make sure 1 mole sahaja. And then don't forget to include your delta H here. Kena tahu delta H ni bukan yang tinggi ni. Kita dah belajar kan yang ni dalam collisions theory?
Yes, miss.
Yes, kalau collision theory kita ingat recall balik, reactant to transition state is EA, but then reactant to product is delta H. So your delta H kat sini lah. And make sure kalau 90.7 positive, the arrow must pointing upwards. Kalau negative, the arrow pointing downwards. Indicates they are releasing heat. Kalau yang ni dia absorbing heat. Okay, so now yang ni saya besarkan sikit. For second questions, name the enthalpy change for the following reactions. So the first one, we have this lithium chloride in solid states. Once they undergo a reactions, we don't even know yet what kind of reactions. They become aqueous states. So from solid to aqueous states. What is the name of enthalpy change?
Enthalpy of solution.
Enthalpy of solutions. Okay, mana awak tahu the enthalpy of solutions? First, apa hint pertama dia bagi? Macam mana awak nak narrow down the informations?
The state of the product.
Okay, state of product satu hint lah. Ini kena hint besar lah. Sebab kalau awak tak tahu definitions, awak tak boleh nak bagi tahu yang ini adalah enthalpy of solutions. Okay. Sebenarnya yang paling besar hint dia, first kali awak tengok ada delta H. Classify dulu. Siapa positif, siapa negatif. But bear in mind, we also got enthalpy of, kita juga ada heat change kan. Heat change pun kita kena take into account. Sama ada dia positif atau negatif. Lepas tengok negative or positive value, baru tengok dia punya heat. Dia tukar kat mana. Ni kalau case yang tak ingat definitions lah. Tengok pada ni, solid to aqueous, kita tahu dia akan masuk dalam air, nanti dia dissolve. Okay, lepas tu kita tahu lah ini adalah enthalpy of solution. Make sure from compound dia akan jadi ion. Okay, next. Number 2. From half N2 gas plus O2 gas to form NO2 gas and your delta H is positive. So kalau kita tengok positive, means heat is absorbed, right?
Yes, miss.
Okay, bila heat is absorbed, kita tengok, okay, heat absorbed, ada satu je atomizations. Maksudnya combustion tak boleh, apa lagi yang heat release memang tak boleh lah. Sebab apa? Kenapa saya nak emphasize benda ni? You have O2 as well in here, right?
Yes.
O2. Kalau ikutkan kita boleh cakap dia combustion, kan?
Yes.
Yes.
Tapi kita tak boleh dia kata combustions. Okay, tolaklah kejap. Jangan tengok lagi yang N2 ni ada half. Kalau ikutkan O2 pun combustions. Tapi kalau ikut definitions combustions, enthalpy H ni positif ke negatif? Kalau combustion.
Negative.
Negatif. So dia dah disqualified terus. Bukan lagi combustions lah. Awak kena faham yang somehow reactions with O2, dia akan buat formations. Kenapa kalau case ni bukan combustions? Kalau combustions, 1 mole of substance being combusted must be kept to 1 mole. Tapi N2 yang tengah dibakar ni 1 mole ke? N2 yang kita react dengan O2 ni, dia 1 mole ke kita simpan sekarang?
No.
Sebab itulah dia tak eligible untuk jadi combustion. So kena hati-hati jugalah. So apa-apa pun tengok dulu, try to narrow down, barulah kita define dia ni sebagai apa. So this is enthalpy of, tengok siapa yang 1 mole. Product kan, yang 1 mole.
Enthalpy of formation.
Ya, enthalpy of formations of siapa?
NO2 gas.
Yes, NO2 gas. Okay, the third one, we have Ca2 plus gas to become Ca2 plus aqueous. Oh, Ca2 plus. Ni adalah sebenarnya enthalpy of gas to
Hydration.
become aqueous. Hydrations, good. Sebenarnya yang ni macam semalam, hydrations, kalau ikut definitions hydrations, Dia just tukar jadi aqueous lah. Betul lah. Tapi semalam kita beri contoh tak bagi ion kan, kita bagi dalam atom. Yang ni nanti awak akan belajar lebih lagi dalam 2.3 Hass's law. Awak akan jumpa memang dia dari ion jadi ion juga aqueous. Okay. So kita tengok gas to become aqueous lah. And then dia adalah negative. Then we have sodium in solid state to become sodium in gaseous state, both 1 mole. So ini kita panggil, dan dia adalah positif. Kalau positif, kita sama ada heat change dengan heat of atomizations, right?
Yes.
Yes.
So heat of atomizations, can I know the definitions of heat of atomizations?
The heat absorbed when 1 mole of gaseous atoms is formed from its elements.
Is one of gaseous atom from its element kan? Okay, so kita form 1 mole of gaseous atom. So basically kita nak keep dia one gaseous atom comes from their most stable states, their element. Okay, good. This is enthalpy of atomizations. And then we have barium in solid states to react with Cl2 in gaseous states to form BaCl2 in solid states. The delta H is in negative. So this negative indicates it's either heat apa yang boleh jadi?
Combustion.
Combustion pula. Heat change or heat release kan?
Yes.
Okay, dalam heat release kita ada combustions. Applicable tak untuk this reaction undergo combustion?
No.
No.
Combustions require oxygen gas. At the moment you have Cl2 gas, so combustions disqualified. Lagi, apa lagi yang kita rasa boleh ada?
Enthalpy of formation.
Enthalpy of formation sebab
It
kita
can
form,
be positive or negative,
ya,
and 1 mole of product form.
okay, from their most stable states kan? Elements at their most stable states. Sebab barium, barium is in mana barium? Mana barium group berapa? Barium is in group 2 lah. Kalau group 2 basically dia adalah solid, dia metal. Jadi bila dia solid, dia acid is lah Ba, bukan Ba2, bukan Ba3. So dia paling stabil as Ba. Kalau Cl2 sebab dia non-metal, dia tak boleh as Cl sahaja, dia kena Cl2. So in gaseous state, that's why dia form BaCl2 in solid state juga. Okay, good. This is enthalpy of formations. What about the F2 to become F?
Enthalpy of atomization.
Okay, enthalpy of atomizations. First, you look at the positive delta H, and then you have 1 mole of gaseous atom to be formed from their most stable states. Elements dia F2, tapi kita balancekan dengan half. Okay, number 7. Your delta H is negative. Okay, your delta H is negative, and then look for the 1 mole of substance. Siapa 1 mole sekarang?
C2H6.
C2H6 in gaseous states, they are located on the left-hand side of the reactions or on the right-hand side of the reactions.
Left hand side.
Left.
Left-hand side means they are reactant or product?
Reactant.
Reactant, yes. C2H6 undergo reactions with O2, we call them as?
Enthalpy of combustion.
Yes, combustion. So this is enthalpy of combustion. The last one, we have nitric acid in aqueous state to react with sodium hydroxide in aqueous state. So these two are acid and base. To react to form this NaNO3 is the salt together with water. So if you look here, all of them got 1 mole only kan?
Yes.
Okay. Tapi sebab kita tahu acid dengan base to react undergo what kind of reactions?
Neutralization.
So we will focus on the 1 mole of water formed and then look at the delta H. This is negative. Suppose heat of neutralization is heat release or heat change?
Release.
Heat
Heat
release.
release.
So betul lah, yang ni adalah enthalpy of neutralizations. Okay. So sekarang awak diberi reactions untuk dapatkan name of enthalpy. Starting from 2.3 until 2.4, usually dia just bagi name of enthalpy, awak yang kena keluarkan ni sendiri. Name of enthalpy dengan benda ni, dengan dia punya value, awak kena keluarkan the reactions macam itulah. Itu untuk 2.3 and 2.4. Okay, done with 2.1. Okay, now look at the FDF questions. The learning objective is to calculate the heat absorbed or heat released by a substance, and then to calculate the heat capacity of a substance. Okay, heat capacity ni yang mana? Apa simbol heat capacity?
Big
Capital
C.
C.
Capital C, good. Apa simbol untuk heat absorbed or heat released?
Q.
Q, okay, good. Heat, kalau dia kata heat absorbed or released, dia hanyalah Q. Tapi nanti kalau dia minta enthalpy, barulah delta H yang kita relate kepada 1 mole. Okay. So the questions ask you, a 446 gram sample of water is heated from 8.50 degrees C to 74.60 degrees C. So saya mewarnakan dia merah supaya saya nak fokus only on the water. Now the questions ask you to calculate the amount of heat absorbed in kilojoules by the water. Do you see anything about calorimeter setup in here? Or it's just water? Ada tak nampak macam bom calorimeter kot? Simple calorimeter kot? Ada tak dalam soalan ni kalau awak tengok statement ni?
Tak.
Tak ada.
Tak.
Okay, so bila tak ada means kita just rely on, ni je lah yang Q punya formula tu. For Q we have how many formula? Two. Okay, one got mass, another one got no mass lah. Tapi kalau got no mass, your C tu adalah capital C, the heat capacity. Okay, so this is just macam transferring of heat je. Tapi dia tak ada transfer to someone else pun. Jadi kita kira untuk dia seorang-seorang dia je. So untuk water, usually kita ada specific mass. So we got MC delta T. This delta T ni tak perlu pun buat asing. Next time awak terus je masukkan. Okay, so bila kita substitute, untuk substitutions tak perlu pun nak masukkan this unit. Okay, janji final answer betul dia punya unit. Okay, heat absorb, bila kita sebut heat absorb, kenapa kita letak positif? Dia gain kan? Dia gain heat kan?
Yep.
Yeah, okay, right. So kita dapat this value, but then questions ask you to calculate this heat absorb in kilojoules. So kenalah gerakkan 3 titik perpuluhan, from 8 kita gerakkan 1, 2 and 3. So they will become 1 to 3.23 kilojoule. Okay, for the second questions, a lead pellet having a mass of 26.47 gram at 89.98 degrees C. Okay, kita ada pellet tu was placed in a constant pressure calorimeter of negligible heat capacity containing 100 ml of water. Okay, bila kita sebut constant pressure calorimeter, maksudnya kita ada tak setup of calorimeter?
Ada.
Okay, constant pressure calorimeter ni nama lain dia apa?
Simple calorimeter.
Simple calorimeter, maksudnya the setup is in the sepatutnya lah dekat dalam apa kita panggil ni, the polystyrene. Okay, tapi dia cakap of negligible heat capacity, maksudnya dia ignore the apa, heat capacity kan. Heat capacity ni C sahaja, containing 100 ml of water. Maksudnya dia ignore je yang calorimeter tu. Nanti awak tengok kenapa dia cakap macam tu. Okay, so the water temperature rose from 22.5 to 23.17. Maksudnya this 23.17 belongs to final or initial?
Final.
Final. So when these two come in contact, this pellet and water come in contact, okay, walaupun dia sebut constant pressure calorimeter, awak nampak macam simple calorimeter, tetapi dia tak ada pun Q calorimeter. Kenapa saya cakap tak ada Q calorimeter? Sebab dia kata negligible heat capacity. Okay, dia assume macam constant pressure calorimeter, but they are not necessarily in the setup of simple calorimeter. Got it?
Okay.
Yes.
Sebab takut awak nampak constant pressure calorimeter terus awak keluarkan Q solution dengan Q calorimeter. Lepas tu dia cakap negligible, okay, so dia akan rely on Q solution je lah. But then our Q solutions yang kita belajar semalam in simple calorimeter require more than one solutions, is it? Kalau Q solutions, mana kita mencari add dua benda kan? Kita masukkan dua solutions kan?
Yes.
Tapi sekarang awak nampak tak ada dua solution? Awak nampak tak solution dan solutions to combine?
No, miss.
Tak ada. Sekarang ni dia nama je constant pressure calorimeter tapi dia bukan membawa maksud yang simple calorimeter kita belajar semalam tu. Kita kena tengok apa yang dia ada. Kita ada batu yang panas masuk dalam air yang sejuk. So awak boleh fikirkan dia punya setup tu macam mana. Dia just involve heat exchange, is it?
Yes.
Okay.
Yeah.
So bila kita tahu macam ni, kita keluarkan terus. Kita tahu Q reactions equal to Q system plus Q surrounding. Tapi sebab our setup got only pellet and also water, so kita tahu yang panas akan release heat, yang sejuk akan absorb heat. So Q released by metal, tengok juga dia ada tak mass kat sini?
Ada.
Dia ada mass, dia ada temperature, tapi dia tak ada C kan? Okay, tapi kita tengok apa yang dia guna C kat sini. Okay, sebab dia nak cari ni kan, dia kata cari specific heat capacity of PV pellet. So dua-dua ni ada mass, so kita akan guna dua formula yang sama. MC delta T dengan MC delta T. But then, release by metal, kita letak negative sign. Kalau absorb, letak positive sign. Yang ni kena letak negative and positive. Sebab kalau tak letak negative positive, kita bawa ke sana, value dia akan jadi lain. Okay.
Okay.
Okay, lepas tu kita rearrange, kita make sure bawa negatif tu sekali. Negatif ni to the whole thing lah, kecuali C nanti sebab kita akan gerakkan dia. Once kita substitute, kita akan dapat 0.159 joule per gram per degree C. Don't forget the unit. Okay.
Okay, miss.
Right. So proceed to week 3 hour 2. Betul kan? Dah habiskan tutorial untuk week 3 hour 1 tu. Tak ada soalan saya tertinggal kan?
Dah habis.
Dah habis, okay.
Tak ada.
For non-face-to-face questions, the learning objective is to calculate the heat absorbed by a substance and calculate the heat change in constant volume calorimeter, the bomb calorimeter. Okay, so given to you 1 gram sample of aluminium and 1 gram sample of iron are heated from 40 degrees C to 100 degrees C. Which metal has absorbed a greater amount of heat? Okay, dia bagi awak aluminium and iron heated to 40 to 100 degrees C. Tetapi adakah this aluminium and iron in contact or they are being conducted in separate experiment?
Separate.
Separate lah. Walaupun dia bagi tahu ada dua ni, tapi kita tak ada pun belajar kata, dia tak cakap in contact, dia just kata which metal has absorbed a greater amount. So asing-asing lah. So calculations pun asing-asing. Awak rasa formula apa yang awak nak guna untuk Q ni? MC delta T or C delta T?
C delta T.
C delta T. Tapi kat bawah ni dia bagi specific heat capacity. Kalau specific heat capacity, sepatutnya guna formula mana?
MC delta T.
MC delta T, selain daripada this C kecil, kita tahu dia ada mass kan for each of them. So cukuplah information dia. Ada mass, ada small delta C, ada delta T 100 minus 40. So bolehlah kita guna MC delta T. Okay, so MC delta T, kalau calculate dapat 54 joule. Okay, lepas tu kalau Fe pula, kita calculate dapat 26.64 joule. Okay, siapa yang lagi absorb greater amount of heat?
Aluminium.
Aluminium. Kenapa dia absorb greater amount of heat?
Specific heat capacity lagi tinggi.
Ya, specific heat capacity lagi tinggi. Maksudnya the ability for this aluminium to increase 1 gram by 1 degree C is greater. Itulah maksud dia. Kalau dia bagi awak information, dia minta awak explain kan, cakap lah. Maksudnya define balik what is meant by specific heat capacity. Alright, jangan lupa bagi these conclusions. Okay. Next, for this question, in a calorimetry study, powdered xylose C5H10O5 combusted in a bomb calorimeter. The following data was obtained. So we have the mass of xylose burned, 1.183 grams. We have the heat capacity of calorimeter, initial temperature, final temperature. Okay, so bila sebut bomb calorimeter, what comes to your mind mestilah combustions kan? Dia dah cakap juga combusted. Okay, bila combustion, the heat must be released, absorbed or heat change. Kalau combustion,
Released.
heat release. So bila heat release, bila you need to define the heat of combustion, you start with heat released when 1 mole of substance completely combusted in oxygen gas. Okay, so that's how you define the heat of combustions. No need to rely on the specific substance kat situ. And then the second questions, calculate the heat of combustions of xylose in kilojoule per mole. Okay, how do you start? You got only heat capacity, initial calorimeter temperature, final calorimeter temperature. Suppose kalau bomb calorimeter, the formula should be apa? Kalau kita dengar je bomb calorimeter, how do we start? Q reaction sama dengan
MC delta T.
the MC delta T belongs to siapa? Ingat balik setup bomb calorimeter. Dalam bomb calorimeter ada apa? Ada calorimeter, dalam calorimeter tu
Water.
ada apa? Water. So by right, Q reactions kita kena include water and also calorimeter kan?
Yes.
Okay, now information given is about calorimeter only. What about H2O? Dia tak ada lah. Maksudnya salah ke soalan ni? Tak cukup info ke?
Tak.
No, it can be.
Okay, it can also be yang water tak ada kan? Sebab kenapa dia boleh cakap oh water tak ada pun tak apa? Kenapa dia boleh
It is,
cakap macam tu?
it is included in the calorimeter.
Yes, sebab the calorimeter itself tu dia dah play the biggest part of the calorimeter. Jadi water tu dia include sekali dalam tu. So tak jadi masalah pun kalau water tak ada tau. Memang case untuk bomb calorimeter, sometimes dia tak bagi information tentang water. Means terus dia gunakan calorimeter yang ada. Jadi keluarkan formula dia. We know our Q reactions will rely only on Q calorimeter. And then kita akan guna formula of only C delta T. Kenapa C delta T bukan MC delta T? Because they gives you only heat capacity, not the specific heat capacity. Even though you have mass in here, can we include this mass as part of MC delta T? You have mass in here, boleh tak kita kata, Miss ni ada mass, kenapa tak guna MC delta T?
Because the mass belongs to the reactant.
Okay, they belongs to substance yang kita nak combust, but this one belum buat reactions lagi. It's just macam nak bagi tahu dia tak ada pun the water punya mass tu, and dia bagi heat capacity sahaja. So tak perlulah mass. Mass ni bukan belongs to the calorimeter. Okay.
Okay, miss.
Okay, then we substitute the value. Okay, tak perlu pun nak masukkan this unit masa substitutions. And lastly, you'll get negative 18.44 kilojoule. Kita akan dapat immediately kilojoule. Okay, kita akan ada dapat immediately kilojoule sebab dekat sini, your specific heat capacity is in kilojoule. Kalau di dalam joule, nanti minta tukar jadi kilojoule. Okay.
Okay, miss.
Okay, can we just stop until here? The questions ask for heat of combustions and we stop until Q reactions. Can we?
No.
No.
No, we need to proceed with the... Okay, lepas step ni kita kena buat step apa? Is this amount of energy belongs to 1 mole of xylose already?
No.
No.
this negative 18.44 kilojoule only belongs to the substance being combusted, which is the 1.183 gram. But then we don't want them in gram, we want them in mole. Jadi apa yang kita kena buat?
Divide by molar mass.
Yeah, to find the number of
Mole.
Moles.
mole. Okay, so cari number of mole. Where do we get this 150 grams?
Molar mass of xylose.
Yes, of the xylose, the C5H10O5, and then you divide them, you will get your number of mole equal to 7.887 10 to the power of negative 3 mole. And then you know for each for 7.887 10 to the power of negative 3 mole of xylose releases heat of 18.44 kilojoule. But now we want to find only for 1 mole. So untuk 1 mole darab silang we'll get negative 2338.03 kilojoule. Can you stop until here?
No.
No, you have to make a conclusions of
The enthalpy of combustion equals to negative,
equals to
negative 2388.03 kilojoule per mole.
Okay, the last questions, they ask you to form the thermochemical equations. So the thermochemical equations now, you must keep only the C5H10O5 as 1 mole, and the rest you need to balance them together with their most stable states. And lastly, include this as part of your equation. So this is going to be thermochemical equations. Usually the marks given here is 1 or sometimes 2, sebab you ada the states as well. Okay. Proceed to the next question. Calculate the heat change in constant volume calorimeter. Still the same learning objective for face-to-face question. Given to you, the combustions of naphthalene C10H8 can be used to calibrate the capacity of a bomb calorimeter. So dah tahu bomb calorimeter, kita keluarkan dia punya formula lah. Bomb calorimeter sepatutnya ada macam tadi, Q reactions equal to Q water plus Q calorimeter. Okay, and then the heat of combustions of naphthalene is 5132.8 kilojoule per mole. So this time the questions didn't want the heat of combustions. Dia dah bagi siap-siap dah heat of combustions. Kalau ikutkan steps kita tadi, heat of combustions ni kita jumpa from the starts or hujung-hujung.
Apa Miss?
Heat of combustions kita ni, kan, kalau kita buat soalan sebelum ni, heat of combustions dekat awal ke hujung? Dia punya steps. Kat mana kita jumpa heat of combustions? First or last steps?
Last step.
Last steps. Now, dia dah bagi awak heat of combustions. Means, dia akan ada backward punya working. Awak kena start from backward. From yang belakang, kita akan work backwards. Untuk cari apa benda yang dia nak ni. Okay?
Okay Miss.
Okay, so means the questions they tak akan always from Q to find number of mole to find enthalpy. Sometimes they gives you enthalpy, they want you to find Q, they want you to find C, so you have to work backwards. Okay, and then when 0.8210 gram naphthalene was combusted in a calorimeter containing 1000 gram of water, a temperature rise of 4.21 degrees C was observed. So determine the heat capacity of the bomb calorimeter. So I highlighted the statement in green referring to only the naphthalene, maksudnya naphthalene punya. Starting from the enthalpy and then the naphthalene tu boleh cari number of mole. So from here you settlekan dulu untuk naphthalene. And then barulah you masukkan dekat dalam calorimeter kita, the Q reactions. Kalau this red belongs to water, kalau yang biru belongs to calorimeter, yang purple ni yang kita share dua-dua. Okay, boleh ke? Faham ke dia punya signal untuk kita masukkan sekejap lagi from this statement? Saya guna color-color ni.
Faham.
Okay, specific heat capacity of water ni patutnya merah lah, saya tak merahkan pula. So now kita nak start dari mana? This heat of combustions of naphthalene, basically delta H, right?
Yes Miss.
Okay, so delta H, suppose this delta H is included in your thermochemical equations, is it?
Yes.
Yes, so you need to first form the thermochemical equations. So because we say heat of combustions of naphthalene means siapa yang kita kena keep to 1 mole?
Naphthalene.
Naphthalene undergo reactions with
Oxygen.
oxygen to form CO2 and water, then you need to keep only this as 1 mole because this value belongs to per mole. Okay, so this as 1 mole and then the rest you boleh balance kan. Okay, so this is your thermochemical equations. So from here we know for every 1 mole, for every 1 mole of C10H8, you have this amount of heat. But then we want to find only for 0.8210 grams. So you need to first find the number of mole. So we get this number of mole, then do a bit of stoichiometry. Okay, bila kita do a bit of stoichiometry, take this number, bring it here, and you will get a new amount of heat. So this new amount of heat belongs to only the naphthalene being combusted in the reactions. So kita tahu this is our Q reactions, right?
Yes, yes.
Yes, now you have your Q reactions. You want to find the heat capacity of the bomb calorimeter. So this heat capacity symbolized by capital C. So untuk ada capital C, kena ada formula of
C delta T.
C delta T. Okay, dalam case bomb calorimeter, kadang-kadang kita boleh ignore water. For this case, boleh tak kita ignore water? The Q
Tak
water?
boleh.
Tak boleh sebab dia dah bagi, and also you have the specific heat of water. Then proceed to the next part. Okay, we have these Q reactions equal to Q water and Q calorimeter. And then we substitute the value. We want to find only this C calorimeter. No need to include this cal pun tak ada masalah kalau awak nak tulis. Dia kan awak kena tulis tahu benda ni. Benda ni ada markah sebenarnya. Cumanya kalau awak tak, yang ni tulislah. Calorimeter, bolehlah tulis. Tapi memang ada markah kalau awak tulis ni selain substitution, so tolong biasakan tulis. Okay, lepas tu kita substitute value. Okay. Kat sini, saya dah remove dia punya negatif. Sebab sekarang kita nak amount saja and saya nak cari C calorimeter. Jadi C calorimeter ni sebenarnya dia tak ada negatif tau. So kita dah remove dah ada punya value kat sini. Kenapa kita boleh remove? Awak tengok awak nak cari apa juga. Kalau awak nak cari delta T, mungkin contoh awak nak cari T final ke T initial, yes, you must include lah. Takut jadi value dia patut lagi tinggi ke rendah. Tapi kalau nak cari C, nak cari mass, you boleh remove dah ada negatif. Faham ke?
Faham, Miss.
Okay, kalau kita letak negatif kan dia jadi value lain pula. So tengok apa yang awak nak cari. And lastly, your heat capacity of the calorimeter equal to 3639.9 ataupun you boleh ambil 3640 joule per degree Celsius. Okay, so second questions, we have 0.1326 gram of aluminium was completely combusted in a constant volume bomb calorimeter with the heat capacity of 1410 joule per degree C. Awak ada kelas ke lepas ni pukul 9? Kalau tak saya sambung sikit 9/9:10.
Tak ada kelas.
Tak ada Okay, saya habis yang sampai 9:10 je sebab tadi saya start 8:10. Okay, so heat capacity dah bagi and highlighted in blue sebab dia belongs to only calorimeter. The green one belongs to the aluminium being combusted. Okay, the bomb calorimeter was surrounded by 800 gram of water, so this belongs to Q water. So the temperature of the bomb and water increased by 1.726 degrees C. This is the delta C shared by both calorimeter and water. Now calculate the heat of combustions of aluminium in kilojoule per mole. Yang ni kita akan work forward lah macam biasa. So how do we start? Can we already find the Q reactions?
Q reaction equals to Q water plus Q calorimeter.
Okay, Q water plus Q calorimeter. Dia sebenarnya tak kisah lah macam mana awak nak susun pun. Tapi saya suka every time awak dapat soalan, awak keluarkan dulu dia punya thermochemical equations tau.
Okay, Miss.
Okay, keluarkan thermochemical equation. Macam yang ni saya start dengan number of mole dulu, dia ikut lah. Awak nak cari Q pun boleh je dulu. Nak cari number of mole dulu pun boleh. Okay, so kita keluarkan Q reactions. Dia tak kisah tau mana awak nak buat step ikut suka awak yang selesa. Tapi saya suka step tadi. Ni tak tahulah kenapa saya letak mole dulu. Awak start dengan Q, nanti awak buat one by one, okay? Okay, lepas tu kita substitute value, kita akan dapat negative 8205.4 joule only. The negative sebab combustions. Now you know this amount of heat belongs to only this number of mole. But we want to find the heat of combustions for every 1 mole of aluminium being combusted. Mean we are going to do the stoichiometry in here. This amount releases heat of this amount. If we got 1 mole, then we have 1670820.6. If we change it to kilojoule, what would the heat content be? Kalau untuk 1 mole, kalau tukar jadi kilojoule. For 1 mole of aluminium, how much heat to be released if we are about to change it to kilojoule?
1670.8206 kilojoule.
Okay, good. Okay, once we change it to this kilojoule, then we need to write the conclusions of enthalpy of combustion is equal to negative. Jangan lupa nak include this negative together with the unit lah, kilojoule per mole. Okay, naklah sikit lagi sebab kita tak buat lagi constant pressure calorimeter, constant volume calorimeter. Ni kita akan buat sikit, ini burn lagi. Ni yang ni apa? 2.4 gram sample of carbon is burnt in a calorimeter given that HF for CO2 is negative 394. Okay, this time dia guna enthalpy of formations. Delta HF ni adalah formations So combustion ni it can be formations and combustion as well. Tengok dia punya enthalpy apa dia bagi. And the heat capacity of the calorimeter is 10 kilojoule per degree C. Calculate the temperature change of the calorimeter. So how do you start?
Thermochemical equation.
Yes, thermochemical equations. Kalau formation, siapa yang kena 1 mole?
Product
Produk kita siapa sekarang?
CO2.
CO2 to be formed from what kind of reactant? Siapa reactant kita?
Carbon and oxygen.
Yes, carbon and oxygen to react to form CO2 in gaseous state. So delta HF equal to negative 394 kilojoule per mole because of this 1 mole of CO2 gas. Okay, they want to find temperature change. In which formula yang kita ada temperature change? Delta T.
MC delta T.
M ke? Ada M ke kena?
Oh, C delta T, sorry.
Only the C delta T. Kenapa only the C delta T? Okay, kita tengok dalam soalan ni. Ada tak dia bagi, dia cakap burn in the calorimeter by right? Bomb calorimeter lah kan?
Yes.
Okay, bila bomb calorimeter, suppose you have water and also calorimeter set up. Is it?
Yes.
Do you have any information about water given here?
No, miss.
No, so that's why we don't use the MC delta T. We want only C delta T for this case. But then you have information about 1 mole of carbon dioxide being formed. But then the carbon dioxide being formed ni will rely only on the 2.4 gram of sample of carbon. Okay, jadi somehow kita kena cari dulu berapa mole yang akan dapatkan that amount kan?
Yes, miss.
Okay, so kita cari dulu number of mole untuk carbon tu. Okay, lepas tu kita bagi tahu dia sebab sekarang ni this 394 comes from CO2 1. So dia sama lah juga 1 mole untuk dia ni. Sebab tu kita boleh guna je lah this value. Dapatkan number of mole. We know 1 mole of C releases negative 394 kilojoule juga. Sebab ni dia guna balik. Sebab dia kan 1 mole, 1 mole, 1 mole kan.
Yes, miss.
Okay, lepas tu for every 0.20 mole, kita akan guna 78.8 kilojoule only. So this is gonna be your Q reactions. Okay, this is your Q reactions. Then if you relate to the setup, you got only Q calorimeter, is it?
Yes.
Because you want to find delta T, only the delta T, not the temperature final or initial. You can simply take out the negative sign from your substitutions and then you calculate them. Okay, awak perlu tak nak tukar 78.8 kilojoule ni to become joule?
Tak perlu.
Tak perlu because your C already got K, then you can just cancel them out. And lastly, your delta T will be, ini patutnya carbon, okay? Thank you.
Okay, miss.
Yang ni tak ada dah, the negative ni sebab kita dah ada change kan difference. The delta tu only 7.88 sahaja.
Okay, miss.
Alright, sikit lagi, saya nak sikit. Okay, and then ni baru nak masuk coffee cup calorimeter, which is the simple calorimeter. So you have both sodium hydroxide and HCl. Do you think their number of mole will be the same if you got different volume?
No.
No. So bila no, maksudnya you nanti kena carilah number of mole, tak boleh assume dia orang sama. Okay, the temperature rose from 25 to 30 degrees C. Calculate the heat of neutralization. So basically ni starts from Q, undergo number of mole, lepas tu akan dapat the delta H. Okay, so dia dah bagi juga specific heat of the solutions is 4.18 joule per gram per degree C. Means for both NaOH dengan HCl ni kan diorang kan gabung, nanti kita akan guna this small letter C. And the density is 1 gram per mil. The reason why they give you this density is not to be used in your calculations, but they want to tell you that this volume can be changed, can be converted into gram by using this density. Tapi perlu tak kita tunjuk macam mana awak tukar?
Tak perlu.
Tak perlu. Okay, so terus je. So kita tahu for coffee cup calorimeter, the Q reactions includes apa dalam tu? We have
Q solution plus Q calorimeter.
yeah, Q solutions plus Q calorimeter. Okay, each and every time tolong tulis dia punya thermochemical equation So, saya cari number of mole dulu. Okay, yang saya buat ni sebab saya tak terus kira Q, kita cari number of mole. So dapat number of mole because these two dia different. Jadi awak tak boleh assume kata yang kecil tu akan jadi limiting reactant. You still need to do the stoichiometry in here. Okay, kalau you perlukan 1 mole HCl means 1 mole sodium hydroxide. Kalau you ada 0.1 mole, barulah 0.1 mole sodium hydroxide. Therefore, HCl is a limiting reactant, then only you can take this number of mole to be used in your heat of neutralization calculations. And proceed with your Q. Saya fast forward, kita akan dapat 7315 joule negatif. Okay, yang ni okay ke saya skip? Kita tak ada apa, tak ada calorimeter informations kan?
Yep.
So kita boleh ignore sebab memang ada certain cases for coffee cup calorimeter yang kita tak ada water sebab dia dah masuk dalam solution. Dia tak ada calorimeter sebab dia punya biggest part is solutions. And then from this Q reactions, we know this amount of heat belongs to this number of mole. And we need to do a bit of stoichiometry. Kita check balik. Oh, before that. These neutralization reactions rely on this 1 mole of H2O formed. Just now, you only find the mole for HCl and sodium hydroxide. You can't simply take 0.15 mole of this limiting reactant just because they are limiting. Awak kena buat sikit statement bagi tahu yang bila mole of HCl, NaOH sama, means mole of water pun akan sama. Kena ada this step untuk bagi tahu we are now about to change to water. No longer HCl, no longer NaOH. Boleh?
Okay.
Okay. Lepas tu, you tahu for every 0.15 mole H2O releases heat of 7315 joule. What if for 1 mole? So 1 mole, darab silang, you'll get 48760 joule. So this joule, kita tukar jadi kilojoule, you'll get 48.76 kilojoule. And lastly, your heat of neutralization is going to be negative 48.76 kilojoule per mole. For face-to-face questions, a quantity of 85 ml of 0.900 molar HCl is mixed with 50 ml of 0.900 molar KOH. You got different volume in here, even though you have same molarity, you are going to have two different number of mole, is it?
Yes.
Okay, so kena bear in mind yang kita tak boleh kata yang ni saja. So dia cakap lagi heat capacity of 3 to 5 joule per degree C. This belongs to calorimeter. If the initial temperature of both solutions are the same, 18.24 degrees C, calculate the final temperature. Dia nak final temperature, the T2. So the heat of neutralization is negative 56.2 kilojoule per mole. Assume the density and specific heat of the solutions are the same as those for water. Density of water is 1 gram per mil. specific heat of water, specific heat capacity of water is 4.18 joule per gram per degree C. Mana dapat value ni? Dia ada dekat depan table of constants. So how do you start? You know the heat of neutralizations untuk water. Jadi kita nak kena buat apa dulu? First sentence dia. Delta H kita nak keluarkan apa? Cepat awak. Kita nak ambil
Equation.
yeah, the thermochemical equations. Keep on you gonna react KOH and HCl to form water and your salt. And then make sure on the water is 1 mole, everything else boleh berubah. Then you have this number. Okay, so from here, lepas tu kita nak buat apa? Bila kita react these two, adakah reactions berlaku tu untuk 1 mole?
No, Miss.
No, jadi kita kena cari number of mole dulu kan, nak tahu amount of heat kita nanti belongs to how many joules kan.
Betul.
Okay, jadi kita buat dulu, cari dua-dua mole ni, both HCl dengan KOH. They got different value. Can you simply take, yeah, this one is smaller. That's why lah kita ambil limiting reactant. Boleh ke terus buat conclusions macam tu?
No.
Tak boleh. So you first need to do a bit of stoichiometry showing who's going to be the limiting reactant. Now we take this small value and then we compare. Then you could see this HCl ni is in excess lah sebab initially they got 0.0765 but then they are left with only 0.045 to be used. Okay, therefore we could say KOH is a limiting reactant. Then we're going to take this number to find the heat released. Okay, so kita pun buat lagi stoichiometry. Kali ni, we know the mole of water pun akan sama dengan mole of H2O, mole of KOH tadi, 0.0545 mole. And then, kita cari dia punya heat release, you'll get negative 2529 joule. Do we need to change it to kilojoule? Perlu tak nak tukar kilojoule?
Perlu, Miss.
Kenapa perlu? Kita nak cari apa? Sekejap, kenapa perlu? Belajar tengok soalan balik. Perlu tak kita nak tukar kilojoule?
No.
No. Okay.
Oh, tak perlu, Miss.
Tak perlu. Yang sebelum ni kita tukar, depends information given. Sebab now we want to find the final temperature, the T. So the T somehow require formula of Q. In your Q, you have MC delta T and C delta T. But now your C given here is only in joule, tak ada kilojoule. Jadi tak perlulah tukar kilojoule.
Okay, Miss. Faham, Miss.
Okay, so keep on with the joule, then masukkan dalam formula kita. Our formula now, this coffee cup calorimeter got both solution and calorimeter informations. Then you're going to substitute these these values into the reactions, into this equation, sorry. You have the Q reactions yang kita dapat tadi. Okay. Okay, sebab sekarang ni saya tak letak negatif sebab saya nak tarik dia sebagai delta T sahaja. Keluarkan as delta T. Tapi you are free to change it to become T2 minus T1. Ikutlah mana yang awak selesa. Macam saya serabut kalau letak terus T2 dengan T1. Jadi saya keluarkan delta T dahulu. So saya dah buang yang ni sebab delta T kita difference je, tak ada pun negatif positif. Nanti baru kita kira. Kalau awak tukar T2 minus T1, then you have to include the negative 2529. Sebab kita tak tahu siapa tinggi, siapa rendah kan. Okay. Lepas tu, once kita substitute, make sure ada 2 tau kat sini. Jadi kena hati-hati juga. Bukannya satu je, satu lagi tak ada. You will get delta T of 2.84 degrees C. Once you got this delta T equal to 2.84 degrees C, you want to find only the final temperature, is it?
Yes, Miss.
Okay, the initial temperature dia dah bagi. Jadi kita just masukkan je lah T2 minus T1. And lastly, you will get 21.08 degrees C. Okay, ni maksudnya rearrange lah. I rearrange ni. Dia dapat T2 dia. Okay, boleh ke yang ni? Last one. Boleh ke saya nak habiskan?
Boleh.
Boleh.
Okay. So in an experiment to measure the enthalpy change of neutralizations, 25 ml of 1.0 molar HCl is placed in a polystyrene cup at the same temperature. 25 ml of 1.0 molar sodium hydroxide is added and stirred. Kalau kita tengok, both HCl and also sodium hydroxide got the same number of volume and also molarity, right?
Yes.
Yes, Miss.
So kita dah tahu dah dia punya number of mole akan sama je lah. Tapi still kena tunjuk jugalah dia punya calculations. The temperature of the resulting solutions increases by 7 degrees C. So this is going to be your delta T. Calculate the enthalpy of neutralization. So ini kita akan buat forward punya working. So you gotta first start with apa? Okay, kita tahu. Ya, thermochemical equation pun boleh, tapi yang ni saya rasa saya buat later on kot. Tapi make sure adalah thermochemical equation. So, okay, good. So, Q reactions now. We know usually Q reactions for coffee cup calorimeter got both solutions and calorimeter kan?
Yes.
But this time, kenapa kita tak ada calorimeter? Kita dalam kita punya expression ni.
They didn't give it.
Yeah, they didn't give it. Dia tak bagi pun information about calorimeters. So we can simply ignore them. Okay, lepas tu saya letak negatif sebab neutralization is heat release. Tu je lah. Kalau tak nak letak lagi pun tak apa. Then you substitute the value. All the value dah ada. 50 gram. Mana dapat 50 gram?
25 mil tambah 25 mil, lepas tu darah dengan density.
Ya, direct density. Dia tak tunjuk pun dapat 50 gram. Okay, good. 4.18 sebab dia kata assume the specific heat capacity of the final solutions are the same as water. So this value dapat dari table of constant. Ini adalah delta T yang dia bagi. Lastly, you'll get negative 1463 joule for these reactions. Okay, but then how do we know how many moles yang kita guna untuk dapatkan this amount of heat? So kita kena buat sikit lah calculations of mole kita. Kita cari je dua-dua walaupun sama. Bagi tahu yang neither in excess. Sama. Okay, bagi tahu yang ni paling penting kena emphasize mole water ni adalah dia ni sebab enthalpy rely on water. Okay, and then buat je macam biasa stoichiometry. Bagi tahu dapat 1 mole untuk 58520 joule. Now, kita nak cari enthalpy of neutralization kan? Kena tukar kilojoule tak?
Yes.
Yes, tukar
Yes.
kilojoule. And lastly, your final conclusions, enthalpy of neutralization. Boleh je heat of neutralization boleh, enthalpy of neutralization pun boleh. Equal to negative 58.52 kilojoule per mole. Saya rasa dah habis. Okay, dah habis. Thank you so much awak bagi saya tambah masa.
Thank you, Miss.
Yeah, thank you everyone. Okay, have a nice
Thank you,
weekend. Esok kita tak ada
Thank you,
ganti.
Miss.
Thank you, Miss.
Okay, right. Jumpa
Thank
hari
you,
nanti. Okay?
Okay, Miss.
Okay, bye. Assalamualaikum.
Bye, Miss.
Ya. Salam.